Hi, Fiona. Hi, Robbie. Hi, everyone.
Zhao, hello, welcome.
Thanks for having me.
Tell us a little bit about your role on the Redshift service team.
Okay. My name is Xiao. I am a applied scientist on the AWS Redshift team. I'm one of the developers behind this Amazon Q generated SQL feature for the Redshift query editor.
Okay,
So my main responsibility is on algorithmic design and making sure the AI model behind this is uh, behaving as expected and making sure it addresses as many customers' use cases as possible.
okay, awesome. Well, thanks for being here, Zhao. So let's just break this down a little bit more for everyone.
Mm-hmm.
So you said that you are on the team for Q for developer, specifically for SQL in Redshift. So just for everyone's background knowledge, this sits on the large umbrella of Q services. So Zhao, correct me if I'm wrong here, but my understanding is that we have this whole suite of Q services, and that spans, Q developer, Q for business, all kinds of Gen AI capabilities. And one of the Q umbrella features is Q developer. And Q developer does code generation. And so within the Q developer umbrella, even more specifically sits what you're working on, which is Q developer for SQL for Redshift. So is that right?
Yep, you're exactly right.
Okay, perfect. And so, Robbie, I know you wanted to dive into a little bit about why someone might use Redshift. And maybe, Zhao, do you have any insight for us there?
Sure. So Amazon Redshift is a data warehouse product optimized for data analytics workloads. Let's say you have a bunch of data and then they're in tabular formats, and you want to find, let's say, what's the revenue from last quarter, things like that. You want to explore your data a little bit. So this is for you. Um, you may heard other things like database, data lakes. So database mostly is for keeping your data fresh, and data lake you can have all kinds of data, but data warehousing is for your analytics workload.
And so as we think about the universal problem statement here, I harken back to developer productivity. We want to be as effective as we can be. Oftentimes there's churn in amongst data analysts. You're coming into a job new and you've got troves and troves of data, petabytes. You don't know the schema. You've never seen these tables before in your life. And you have to inherit all of these incredibly complex queries you've never seen before. And
Right.
what I'm hearing you say, Joao, is that through generative SQL, sure, you could use Amazon Q Developer in your interactive development environment of choice and ask a question, hey, how do I write a SQL query to get the maximum number of views of this page, as an example? But it wouldn't be contextually relevant because it wouldn't know your schema, it wouldn't know your tables. But for generative SQL, this is unique to your data sources, right?
Oh, right. So what we are offering here is a code generating assistant that can generate SQL that is personalized to your data. So understand the schema, understand what should be used to answer certain questions. So yeah, you're right.
Okay, awesome. And so when we're thinking about who this is, I don't know if anyone can hear the siren in the background. Don't mind that. If you're thinking about who is the target customer here, who this really benefits, would you say something that's best for someone who's technical and really has a deep understanding of SQL already, or is this for people who maybe don't have as much experience with SQL?
It could be for both. So let's say you're a non-technical user, right? So your boss asks you to get the revenue number from last quarter, right? You probably have to dig through the definitions of your data, like go through documentations, what are the available tables, what are the available columns, and also you have to probably refresh your memory on how to write SQL. So you have to do all that to be able to write a SQL, right? So this assistant can jumpstart that process. Basically, you can ask natural language; it will give you a pretty good SQL to begin with. At the same time, it can also work for a technical user because the SQL gets complicated real fast. You're probably going to write a very complex compound queries that consists of multiple tables, multiple columns. So this virtual assistant is also conversational. Let's say you have some idea how to write SQL, but you can work with this assistant to build that complex SQL.
Okay. Okay. So what I'm hearing is that if I'm a technical person, this is going to help me because it has that understanding of my database. I can walk in, even if this is my first time seeing the database. It'll help me and give me an understanding of the way things are set up. So it's good for a technical customer. Also, if I'm non-technical, I can write in natural language what it is that I'm looking to grab from the database, and it'll give it to me in that case as well. So both technical, non-technical people can benefit from this.
That's correct. So one more thing I want to highlight here is very secure, meaning that none of the natural language you issue to this system or the underlying data will be used to train or tune the foundation model behind it. So it's very secure. We won't use your data for that.
Well, I'd love to see a demo of this. I know that you've had prepared. Early this morning, I had a chance to take a look at generative SQL within the console in Redshift. And one of the things I loved is the consistent developer experience. Mm-hmm. The Amazon Q Network Reachability Analysis tool looked a whole lot like how I use Q Developer in my IDE, which looked a whole lot like the experience in the query editor. And I think that consistent experience to developers across all these different modes of Q Developer has really made this such an exciting feature since it previewed at reInvent. So with that, Joe, want to take us through the demo?
Sure.
Yeah, definitely. And just before we go in, I want to say one final call out for that survey with our with the fall baked goods. Please do let us know in there. And then also, I mean, we mentioned that this is a great service for both technical and non-technical audiences. So if you guys wouldn't mind, just in the chat, shout out and let us know, what kind of experience you have with SQL, how you think this might, apply to use cases that you have. And then, Zhao, as you're going through, we can see how it might work out with the viewers.
Sure. I'm going to use a second monitor to give you the demo. So if I'm looking elsewhere, I'm not watching a movie or answering to my boss. So yeah. So maybe let's start with one of the landing page of Redshift. This is, you can see my screen, right?
Yes, we can.
Okay. So we want to quickly get into the query editor where you write SQL. So there's a button here. You click on this. Okay, let me share the new tab. So this is the query editor. So the way you have to enable this queue, right? So at the bottom left, there's a button here. It's Q Generative SQL settings. And there's a box you have to check to enable this Q Generative SQL feature. You have to be an admin to check this box. Because okay. I'm the admin, so I do whatever I want.
So people working in the console who don't have admin privileges will need their admin to enable this for them.
That's correct.
Got it.
And this queue is available in the notebook. So you have to create a notebook here. Once you have done that, you will see this little button here is Amazon Q Generative SQL. Click on this. It says, okay, you have to connect to a database. Okay, so let me briefly talk about the sample database I'm going to use for this demo. So we have a sample database called TBCD. The database is called Sample Data Dev, and in it there's a schema. It's called TPCDS. TPC is a benchmark for evaluating various database performances. So here we have 25 tables. Get it?
Okay.
Just quickly show you this. So we're gonna let the queue connect to this particular database.
And this database is being housed in a Redshift cluster. So prerequisite is admin privileges and having created a Redshift cluster of which you can load tables, including sample data that's readily available.
That's correct.
Okay, so you have this sample data set here that we're using today, and this is just generic example customer data. So maybe like, what does it say we have here? Okay, we have some catalog pages, we have customer addresses, inventory, and items. Okay, so just pretty standard customer data.
Yes, that's correct. You have stored information, sales information. So this is a public benchmark.
Got it.
So we click on this, so you can see the queue just pop up, and you can start to actually ask questions. Okay, let's go with the first question. Let's say we ask, okay, what was the unique identifier identifier of the top selling item.
Okay, and so here we're
Or-
just looking through your just generic database, right?
Yes.
All right, so maybe let's come up with what we think this use case could be. If you're those who are watching, we're looking through just an example of what a store might be with some items, and we're looking for the best-selling item. If you were to have a store, what would you sell? Let's get some ideas in the comments, and we can run with that as we're going through this example. If you could have a store, what kind of store would you have, and what are you selling?
I would sell pumpkins, and that's extremely lame. So that's come up with something better. Where's?
Someone's selling shares. Okay.
Okay.
I like that.
Oh God.
All right, let's get anyone selling ice cream? Come on, guys.
Yeah.
I personally would have an ice cream store. Shoes. All right, I like it. We'll have a shoe store. And we're looking for the most. Okay, love it. Naughty Sock says that we have a shoe store. And now we're looking for the most sold item. So maybe it's a boot. We'll see what it is. All right, so we generated that code. Do you want to walk us through what's going on now?
Yeah, sure. So it took a few seconds to generate a SQL. I didn't write this. This is generated by our assistant. So basically what happened is it first tried to understand your questions, and then it creates a knowledge base based on your data, and then try to find the appropriate knowledge to sort of generate a SQL. So what we ask here is, okay, what's the unique identifier of the top selling item for the store, right? So most likely we're gonna use multiple tables here. That's what the assistant did. So it uses item, which store all the item informations because we're asking about the item. And also it goes through the sales table to see, okay, to see the transactions, like the number of sales and all that. And of course, it should be sold from store, not any other channel. So this SQL actually covers the right tables. And then what we ask for is the unique item, right? So it returns the ID.
Awesome. Okay, so if I'm someone who understands SQL, this has just given me some code and I didn't have to write it myself. If I'm
Right.
someone who doesn't have knowledge of how to use SQL, if I don't know about the fact that, there's disparate tables and we have to join them together to find something based on a key that, links two tables together, I don't even need to understand that. I just have to tell it, hey, I want the top selling item for this store, and it'll spit out all that code for me.
That's correct. And so with one click of a button, we can actually add this to the query editor, and you can quickly test it out by running it. So,
We have a syntax error.
okay, let me try that again.
Maybe a rerun.
Yep.
Or could you send it back to generative Amazon Q generative SQL?
Yeah, you can do that. So basically you can attach the arrow here and says, okay, there's error message here.
So this is really clean, because before you could still, in your IDE of choice, if you had the Amazon Q extension, you could still send the error. But again, it wouldn't have any knowledge of your specific data scheme, and it would just be operating on the error in isolation. But now you've got real-time feedback that's fundamentally context-aware.
Yeah, it was probably a web page issue. So now, so with this error message, actually it corrects it. So now it actually give you a ID. And
I happen to know that ID is for boots. So I was actually correct that the most sold item is in fact boots in the shoe store.
Sure. So if we're going to continue with this example, so I mean, this question is not that meaningful because it wasn't constrained by time. So you can actually continue to build on this. Let's say, can you filter by the year 1998, right?
So now we're looking for the type of shoe that was most sold in 98, but we don't have to tell it what shoe was the top seller in 1998 because it remembers that from previously in the conversation.
That's correct.
Sweet,
So
keeps that context.
looking at this SQL, so to be able to have this time constraint, it also add another table, date dimension table. And then we have an additional predicates here that defines that constraint of time is 98. So, and also we can just quickly run this. And there you have the ID.
The kitten heel, of course, yes.
So now you have the results. One thing that we have here is the feedback button here. So if you really like this, you can hit the sum up. And if you don't like it, you can actually share more feedback, like why you don't like it with us, so we can improve. So you can select, okay, the SQL has incorrect tables or column in it, or it has a SQL structure that is not right for my data. So you can share this with us. And I'm also going to demo a safety feature. So because using SQL, you can actually modify your data, right? So let's say we want to increase the sales price of every item in the web sales table by $100.
All right, so now we're doing something like chili. It's getting spicy up in here. So we're not just reading from the database. We're asking it to give us some code to actually do a write into the database.
Right. So,
and what happens when you do that?
So the assistant will, of course, find the right tables here, which is the web sales. And also it does this, the thing that we asked for, which is increase the sales price by $100. Since this SQL will change your data, so we will give you a message. A virtual assistant will give you a message saying that, okay, you're going to change the data. Be careful with it.
Wow. So this allows the junior developer an additional set of guardrails on top of the fact that things like IAM rules still apply. If you don't have access to that data, depending on what those permissions are, you can't query it or you can't delete it. IAM still applies, which I think is a super important safety feature.
Yeah, that's correct, Robbie. So whatever safety feature you have with Redshift is still there. This is not going to affect that. Okay, I can probably demo another very cool feature. So let's say I want to ask, okay, what's my favorite stores in 1990, right?
All right, so now you're asking it for a question that's specific to you. What's your favorite store? Like my favorite spice is licorice, but if I had a database of spices, my database wouldn't know how to tell what my favorite is because it doesn't have any context. And so it's saying here, I can't generate any SQL because I don't have the context. So is there a way that you can give it context how to know what your favorite is?
Yeah, that's correct. So this happens to a lot of our customer. Basically, they have their own knowledge base. They want the virtual assistant to know, to be aware of, so that when it generates SQL, it also personalized to their knowledge base. So we offer this feature is called customer context.
Okay.
So the way you get there is you still go through this Q-generative SQL settings. And then there's this button here, add customer context. Okay, so there are many fields, there are many types of knowledge we can provide it to the system. You can check it out on our AWS documentation webpage. So I'm gonna give just try one thing here. So I prepared this already. So let me just put it here. you don't have to pay too much attention on this resource type. But what I'm trying to do here is, let's say, what's my favorite store in 1999 is already something defined by your organization, right? So it basically, it is the top selling stores in 1999. So this is how you define the answer for these questions. And you want the virtual assistant to be aware of that. So now
if I were to have a store and I wanted to tell it what my favorite food is, I just have to say, you know, find something that has ginger and garlic. That's going to be my favorite food. And so then if I say, what's my favorite food? It has that context. It knows search for something with those spices and it'll pull it up for me. And so what you've done is you've given it the context of search for the store that has the most sales in a year, and that will be my favorite. And then now when you interact with the conversation, you can just say, hey, what's my favorite? It has that context in the background already. You don't need to tell it all that extra knowledge. You just have to ask, what's my favorite?
That's correct.
Got it.
So let's say, what's my favorite stores in 1999? Now it knows the answer. Just to show that it's not just remembering this, let me see if it can generalize to other years. What's my favorite stores in 95?
All right, so you're just showing us that it's not copy and paste, that it really is using that context that you just gave it.
That's correct. So nice. Okay, you have the correct predicates here. It's 1995.
So Zhao, we only have about 1 minute left here. What do you want the audience to do if they want to learn more about generative SQL, specifically on Redshift? How should they get started?
Yeah, just start using it. So it's very easy to use. You just if you click off a button and ask natural language questions, and make sure you ask crazy questions. So we want to collect more use cases and share feedback with us so that we can improve.
Yeah, definitely. And I also want to acknowledge, we had one comment in the chat and it says, imagine a junior dev running these queries on prod without understanding anything. And I think that's such a funny comment. And it's actually a great kind of point to the feature that Zhao was showing us with that responsibility feature, where it gives us that warning. So you don't need to worry about, you know, this opening up people being able to make actions that they wouldn't have previously been able to make, because those IAM permissions are still applying. And it'll also give that junior dev a warning notice. So if a junior dev that doesn't have access to make changes to the table, only has read permissions, for example, pulls up that code, it's going to say, you know, you can't do this. And then they might even try to do it. They don't have the permissions. It doesn't work. So it does have the safeguards to, you know, warn them about that with the service itself.
All righty. Well, it's time to move to our next segment here. Zhao, this was awesome. Great example of generative SQL, natively integrated into the console, easy to use, accessible to all. Awesome to have you on the show, and we hope to have you back soon.
Thank you.
Thanks so much, Zhao.